time time period can be limited, but to what extent it can be limited? The question comes that any activity which has to start, whether it's a dam, water storage system, or it's a water conductor system, or it is hydromechanical, or is a power plant, and whatever activity, whatever you do, everything, your design and engineering has to be perfectly matching to the requirement. And until unless it is matched with the requirement of the projects and plant, you will not be able to reduce the gestation period of the project. And once we will be able to reduce the gestation period of the project will be all the time, it's not only, it will pay you off, as I just now said about Rampur. If you can do something in 1 year advance, you can understand how much interest you are going to save and how much extra generation you are putting up to the category of our company. And likewise, this is one of the important point I just now shared with you. Then major slippages, that also the people, our respected guests, they have already discussed in the beginning. I promised I will not come in between my presentation and your lunch. So delay in preparation of DPR and MOU signing, this has been done by our colleague from TSDC. They have deliberated in detail. Delay in MOEF clearances, they have also talked about. Delay in award of works, this is in our hand. If this award of works and this delay, this we cannot compromise with, because this is in our hand. Then comes your geological surprises and natural calamity. Geological surprises and natural calamity, this can be met when, as I already said, when your project is well investigated and all these geological and or geophysical data you are having ready on your table, you can minimize geological surprises and natural calamity, but you cannot avoid it. And finally, R&R issue and court cases. This also you can avoid court cases also. So if you permit me, I will take a minute to explain you that while commissioning Rampur project and that outgoing line was going to some tower, and there was a farmer there, and he was claiming compensation to the tune of 1 crore or 2 crore. I talked to the CMD Power Grid at that point of time. He said, I have already filed a case in the High Court, and please don't worry, I will be trying and getting it. Dear friends, you all, with the help of all of you from SJVN, I like to tell you, you may remember it, that same problem which has been sorted out by ourselves by taking the connection of the Rampur project with 2 towers preceding to that, and that arrangement which has been made. And I was told this arrangement is still going on there at Rampur, and the same arrangement is still going on, and that original interconnection that has been dispensed with. With this, I think
you have to wind up, Mr. Singh.
So optimization in operation of project, as I already said, this will give you extra MU, extra megawatt, less maintenance time, reduced cost of maintenance, increased plantability. And as I told you, this is the chart as I was talking to you. After 14-15, I could not collect the data, but you see all your generation was well above the this design energy of a plant, which is 6612 million unit. Thank you.
Thank you. Thank you, Mr. Singh. And now we move on to the next one by Dr. Gopal Dhawan. Please, Dr. Gopal Dhawan, kindly stick to the time limit, please.
Good afternoon, Mr. Chairman, Session Secretary, my co-panelists, and distinguished audience in the hall. Well, I shall be presenting planning and construction of long tunnels in a short time. And although, I am feeling very much nostalgic in this hall because in 1994, we conducted a seminar on accelerated hydropower, development of hydropower in the country, and I happen to be the organizing secretary of this from NHPC, Officers Association. Well, sir, so all of us know that how important are tunnels for development of hydropower. And there's a comprehensive list given in this slide. But the problem is, in my opinion, we are a bit laggard as far as hydropower projects are concerned in completing our tunnels in time. Whereas on the transportation side, a lot of development is taking place, a lot of tunnels are being constructed. USBR tunnel, you already know that it is, some sections are already open. And I think the final commissioning is very close. Then Rishikesh-Karnaprayag tunnel, I must mention that they are doing a good job, and they are doing more than 4 kilometers tunneling per week by more than about 40 phases or so. They are going to deploy TBMs also very shortly. I think it is just being deployed in a day or two. Then Atal tunnels and so many other tunnels, and Sela tunnel is under discussion nowadays because of our standoff with China at Tawang. This picture speaks almost everything about what happens when we construct tunnels and what happens when we do not investigate tunnels properly in the Himalayan terrain. All of you are aware that as far as dams are concerned, we are very investigating dams systematically. For powerhouses, particularly underground powerhouses, we are putting drifts to the end of the powerhouse. But tunnels, somehow, they remain a bit less investigated, and we have to depend mostly on geological mapping. As Mr. Tripathi pointed out, that the other sectors are using the time domain electromagnetic airborne survey, but we are yet to do that. So problem is inaccessibility, complexity of geological structures, then lack of investigation techniques. What is the agenda? You see, there are greater expectations from geologists and engineers today because we have to speed up. Almost, we are required to predict rock mass ratings of along the tunnels in the contract stage itself. But is it possible? Has the technology advanced to that level? How much it matters if the good assessment is available? I know an example of Salal Stage 2 where a parallel tunnel was already being constructed, but I think we could not take advantage of the known geology which was known just 20 meters away from the second stage tunnel. Problems are all known to you. There are 8 problems mentioned in this slide. To save time, I am not going to read them, but you see, cavity formation, occurrence of shear zones, squeezing ground conditions, tunnels running in overburden. These are the problems which we face almost in every long tunnel in some stretch or other. These are some pictures starting from Dulhasti, where the first TBM got stuck, and then it was removed, and finally the tunnel was constructed with DBM. Then we have Parvati flooding, we have squeezing in Teesta, we have high temperatures in Dhauliganga, and so on and so forth. What are the reasons? I think we have deliberated a lot on various reasons which are, which are responsible for geological uncertainties, but I think every speaker is pointing out towards the inadequate geological investigations, and I do agree with that, and we need to do something to improve level of our geological investigations. TSDC has done a good thing for Vishnugad Pipalkoti because I happen to be associated there as a member of the panel of experts. They have prepared a good DPR, and we have compared the progress whatever has been done till now, it is matching very well. So that's a good beginning, and in Mangdechu also Mr. A.K. Mishra prepared it, and I was also associated with the preparation of DPR of Mangdechu. So we had conceived preparation of GBR, so that is required. And then we need to do the proper management during construction of these tunnels, and investigation should not finish at DPR level, it should continue, and it should be comprehensive. In case we wish to keep a balance between uncertainties, time overrun, cost overrun, we will have to do quality investigations. Quantity of investigations has to be proper, and we have to give sufficient time. For example, you see, standard budget allocation should be about 5%. But I did an analysis from the CA data, and I found that in most of our own projects, where I was the principal investigator from NHPC, we had not spent more than 1.5% of the total budget of the project. And in some of the projects, even it was less than 1%. So budget has to be increased, and I think the same indication was given today in the morning session by the secretary. And then sufficient time has to be given to DPR, because we prepare DPR, complete it in a very strict time schedule, and then we waste a lot of time, as Mr. A.K. Singh, former CMD NHPC, was telling, that 47 months are required. In NHPC, for several projects, what we have done is, in name of pre-construction investigations, we collected good data before award of contracts. And if you do comprehensive investigation, you will certainly be rewarded by early commissioning, and inadequate investigations will involve several risks. These are the tools of investigations which are available to us, but for tunnels, we start with topography, go to geological investigations, and then for most of the projects, either we do some small drilling here and there to explore low cover zones. But in my view, and I will show you the geological model, in case we update it with geological investigations, and particularly geophysical investigations, and integrate all these kinds of investigation into one, we are certainly going to be rewarded. And the modern investigation techniques which transport sector is using, LiDAR-based mapping, airborne geophysical surveys, directional drilling, they have made it mandatory now to involve a contractor who can do directional drilling, but I am yet to see application of directional drilling in India as of now. TSP, all of us are using very effectively, and it is giving good results. This is a very simple model which I wanted to convey to you, that after, in case the geological mapping is done in a correct manner and on the right kind of scale, on a good topographic map, you can predict the geological formations along the tunnel. But I am saying geological formations, not the RMR classes, which I call geostructural classes. And with little effort, if we are not required to drill deep up to the invert level. In case you can see there are some weak zones here, particularly with the red line, you can have short drill holes to prove them under the earth. And then geotechnical assessment can follow with good data, and you can avoid, in case your model is correct, you can avoid problematic areas right in the beginning, before finalization of the assignment, alignment. And then along the final alignment, one should do geological risk assessment very, very properly, which I am going to explain. In case our mapping is good, our investigation is good, we will be in a position to give good design parameters through RMRQ, everybody knows, but I am more inclined nowadays to use Austrian method of ground assessment, which is ground type and behavior type. Sometimes later we may discuss about it. And then during construction, we can adopt the good and the best construction practices, particularly by doing 3D mapping. Nowadays, everybody goes for face mapping, and in case we can do that, and now we can use this input for improvising our blast design, do instrumentation. Instrumentation in hydropower sector is one of the areas where we need lot of improvement, because all of us nowadays say we are doing NATM, but NATM without instrumentation cannot be implemented in sense of stricto. Then during construction, we should make certain provision in the contract, and these should be advanced probe drilling, multi-drifting, instrumentation, pipe roofing, etc. This is a very important matrix proposed by McFeet. This is for the risk evaluation. As in the beginning, I have told you there are certain types of problem which you may call risk. Suppose you are expecting that you will be negotiating repeated shear zones. So for every risk you can do this work, and in case you can do that, on one axis we have plotted consequences, and on the other hand is the likelihood of that risk, and then you can estimate R1, R2, R3 and R4. Depending upon the level of risk, you can go ahead with your mitigation measures. These are some pictures from Parvati project where we used pipe roofing for the first time, maybe 15 years ago. And then these are some of the new examples of reinforced rib shotcrete being used by railway tunnels in Rishikesh. This is how these tunnels look. No rib is being used. So that is another takeaway, that we should reduce use of ribs. And these are my concluding remarks, wherein I would say that selection of the right alignment and right contractor, geological risk evaluation has to be done properly, and in case the risk cannot be pinpointed, at least some zones where some kind of problem, like Parvati 2, we knew that water will come, but where it will come was not known. So this has to be done. Adequate provisions in the contract should be done to deal with EGOs, and proper management of risk during construction and quick decision making is key to the success. Thank you very much, sir. I think I finished in time. Thank you.
Thank you, Dr. Dhawan, for giving us a good overview of geological hazards in the tunneling, and also the